How DevOps and network engineering align. You may already be familiar with DevOps. DevOps is a methodology primarily applied to software development and software applications that focuses on delivering value faster to production through a collaborative effort from the point that code is developed to the point that it is actually deployed. More specifically, it's a set of processes, tools, and automation that shortens the life cycle in delivering new features, fixes, and functionality production sooner. The processes employed are collaborative, often using Agile and involving support from multiple organizations, including the product, planning, information technology, engineering, and operations teams. Here, though, we are focused on how DevOps relates to network engineering and dealing with inherent change. Before getting into more detail about DevOps, let's take a look at the strategic goals in running today's sophisticated and widespread data and telecommunications networks. For network management and network engineers, there are 4 key goals in managing networks. These are reliability, availability, agility, and adaptability. Let's take a look at each of these in more depth. When we talk about network reliability, we're referring to the stability of the network and the likelihood of an outage or an event that disrupts service. Basically, it is a measure of failure-free network operations for a period of time. As network engineers, we need to establish, reach, and maintain high reliability in the network to support customers and internal users. To the end user of our networks, we need to provide the same level of service even when one component or one device goes down. Availability is similar to reliability but goes a step further. The network needs to be operational, stable, and also capable of performance as dictated in a service level agreement. In other words, can the network operate at the functional dictated for a period of time? If a circuit is operational at 10 gigabits per second at 99.99% of a month, but meets this baseline only 95% of that time, there's a significant gap in network availability. Agility is another key goal for network engineers. Through new techniques and tools, networks can now be configured and reconfigured quickly to accommodate network usage. This is becoming increasingly important now as companies and enterprises have to adjust to constantly evolving demand on networks, as well as the always morphing threats from cyber espionage. Finally, network adaptability refers to the ability of a network to adapt to changes through analytics and decisions made within network management. What is key is that the network can adapt and not be constrained by complexity and exception to standards. While agility focuses more on speed, adaptability focuses more on applying intelligence and standardization to readily adapt as need or situations occur. To drive home the concepts of reliability, availability, agility, and adaptability, consider a common utility such as water. Given plumbing as a network that provides consistent water delivery, it has to be reliable. Turn on the faucet and water should be delivered. Water also has to be available at the desired state. So if the pipes can support water pressure up to 75 pounds per square inch, then anything exceeding that risks damage. Anything below 40 pounds per square inch may be too low. Further, temperature may need to be adjusted if water is plumbed from a hot water heater. There's a thermostat on hot water heaters that maintain temperature ranges. Next, water delivery has to be agile enough to accommodate changes. If you need to fill an aquarium tank, then you have the option of using a hose or a bucket to extend water to the endpoint. There you can deliver in the quantity or volume needed. Finally, water delivery has to be adaptable. How water is delivered to the endpoint may sometimes need to be a stream and sometimes a spray. There are nozzles or faucets that can readily adapt to both types of needs. Further, you may decide that more efficient faucets or nozzles are necessary to reduce water usage and costs. So just as with a common utility, networks delivering data must focus on these core goals. Anything less results in inefficiency, waste, and significant impacts to internal users, and most importantly, customers. So how do these goals align with software and software development? Surprisingly, they are very similar and align quite remarkably. Just as with network management and network engineering, software and information technology teams are focusing on the same 4 components of application delivery, which are reliability, availability, agility, and adaptability. As with network reliability, software reliability is basically the probability of failure-free software operation for a specified period of time. Again, we're shooting for availability that's as close to 100% as is reasonably possible. For example, an application software that supports a social media or e-commerce site should be available as much as possible, as near to 100% as possible. Here, as with networks, availability is based on reliability, but takes it a step further and measures if the application provides service as designed and responds within set standards. Questions around whether the application responds in a set amount of time, say less than 1 second, or if the application functions bug-free over a day, a week, or a month become important metrics to measure. Software agility is frequently associated with agile methodology that focuses on incremental deliverables and that introduces changes more effectively. Just as what I discussed regarding network agility, the focus here as well is shortening the life cycle, working collaboratively with representatives from multiple areas of the business, and putting changes, fixes, and enhancements into production software sooner to deliver more value to the enterprise. Finally, as with networks, software applications have to be built so that they can adapt easily and efficiently to how the business or the enterprise changes. Non-standard software, complex or confusing software, and custom-built applications can make adaptability difficult and then affect agility. In managing either the network or the software that depends on the network, enterprise goals are very similar for both areas. In recent years, the DevOps methodology has converted many organizations into a model that provides needed reliability, availability, agility, and adaptability. We can now utilize a DevOps model to deliver better network value and improve network maintenance and efficiency. In the next section, I will provide an overview of DevOps and 3 important concepts to support it. These are continuous integration, continuous delivery, and continuous deployment. These are important to truly mastering DevOps for network engineering.